Welcome to Baba Boss channel. In this video, we'll talk about GPU basics for API workload. GPU needed especially for training and inference time. Whenever you are train a model, whatever deep learning model, yeah, LLMs, yeah, VLLM, whatever. The terminology in the GPU he heard about that one is CUDA core, second HBM, VRAM. Well, in this video, we will discuss about all this terminology and how effectively we can use all these things. For uh, in your training, yeah, inference, you need memory capacity and speed. For memory capacity and speed, you need VRAMs. For parallel computing is where you want to do distributed training, yeah, distributed inference itself, that you need CUDA cores, and your data movement would be fast. For that needed again higher memory bandwidth. So all these things we need, especially these kind of GPU capability. Now I will talk about one by one where VRAM can be used. Okay, so VRAM means like video RAMs, and especially it is used for load your model weights, your activations, gradients, attention case if you are training your LLM, like KV case. KV case is memory needed for KV cases for both for training and inference, especially for if you use transformer and it will load your tensors. So that's related to VRAM. Okay, why VRAM is matter? It's always matter. If your model is large, then you need a large VRAMs. If your context means like your input context window eat more VRAM. If it's large, then again you need more VRAMs. And your training and inference both need VRAMs. So roughly intuition, now I will give how effectively you can decide how much VRAM needed for particular models. So especially I will talk about large language model. Uh, Currently architecture that already available, lot of architecture available in the open source where you need VRAMs or any model often shows, for example, Llama Visions, Drawing, lot of blah blah different models. If your model size, your model have that 7 billion parameter, approximate you needed 40 GB VRAMs. If you're 70 billion, then 140 GB VRAMs. And it's load vary if your model quantize. If you quantize 7 billion model with the 8-bit precision, then you need around 4 like it around half of 8 GB around VRAM it's needed. The floating point precision we already discussed in previous videos. Also you can watch that video, what is difference between floating point and BF16, FE16, yeah, INT8, whatever. Quantization is different thing, but where quantization optimize your VRAM a lot. Okay, so this is basics about where we need VRAMs. Another things, if you want to train scratch big GPT kind of model like ChatGPT, then you need high bandwidth memories also. And how high bandwidth memory provide to GPU is stacked up the memory vertically or wide to if you need training and inference, if your context is large and scaling is very large. So, and all the memory is connected with ultra wide buses. So I'm talking about hardware, how hardware is stacked at one together and connect also ultra wide buses, then it will access memory widely for your high speed data flow. Where the matters, like why, especially like I already told, where massive bandwidth witnesses, right? TVs. Okay, you have VRAMs 100, 200, 500, but you need VRAM in TVs, then you need stacked up this memory, that high bandwidth memory. If you want high Like low latency also, it matters. If you give, for example, inference, you are asking something on the prompt, you will get answer in millisecond, microsecond. Then you need this kind of uh, memory, and your matrix size is very big. If happen, your patch size is very high while training. So especially matrix multiplication happen, right? That time you need that kind of VRAM. So that is HBM is helpful. Okay, we discuss about VRAM, HBM. Now we'll talk about CUDA cores. We know all CPU cores. Generally, if you are laptop users, then 4 core, 8 core, yeah, 16 core, 32 core laptop is coming in the market. And if you are Mac user, also some 8 core, 16 core, 12 core um, CPUs with the CPUs. I'm talking CPUs. So math calculation happen on the CPU and math calculation happen on the GPU cores, which is different. GPU cores especially designed for each math calculation, vector math, yeah, element-wise math, matrix multiplication. It's matter like for if you want to design especially GPU core, then flip-flop. Each flip-flop in terms of GPU is different. Flip-flop like each math operations. How many math operation can maintain particular core that depend on the flip-flops. So all things can already optimized in the GPU. So GPU core is specially designed for all this mathematic operation, mathematic computers that help it fast and parallelly it can compute. For example, you are putting a matrix 1000 cross 1000. Then based on available GPU core is divide this matrix. It will do the matrix multiplication in parallelly and get back to you the results. And that's why GPU core is amazing for math calculation. That's why I needed CUDA cores here. And CUDA cores utilizations, CUDA core hardware. NVIDIA already have that firmware that called CUDA libraries that's written in especially C++ and available in any interfaces. So this is all about CUDA cores in basics, where you can think about how you GPU configurations you needed based on your model. In simple way, if you want to do inference, then no need big giant memory, a big course GPU. If you need training, LLM training, definitely you need big one, but inference is okay. You decide based on your available GPU. If you have 20 GB of GPU VRAM, this number of cores, okay, then I can go for this model because 7 billion model with BF16 floating point and 14 GB it will take, remaining 6 GB it will use for if manage your context. If you are passing big context, then again it should need to manage, it need some VRAMs. Based on that, you can decide how much VRAM you need. Thank you so much. If you have any questions, please comment on that. Thank you.